Good morning.
Good
Good morning,
morning.
Deb. Good morning, girls.
Good morning.
Good morning, Deb. Okay, so let's see.
Good morning.
Morning, Deb. Okay, girls. Now before we start, any questions yet? Any questions? So we were yesterday, yes, okay, talking a bit about some different units that we may come across. And a unit that we're going to hear a lot about, or you can say it's okay, it's probably going to be impossible to talk about sound or any kind of waves without talking of frequency. And frequency, that's me, it's okay, that's going to be, it's okay, the number of any event or time. That's going to be, it's okay, what we will call frequency. Clear? Now in ultrasound, that's okay, the number of the event that we are talking about is going to be, it's okay, we can say it's okay, the number of cycles of sound waves. And the time is going to, it's okay, is going to be, it's okay, per second. That's going to be the frequency of the time, of the sound wave. Clear? Okay. Now, we could have expressed it as, okay, as X, Y, Z number of cycles. We could say as, okay, 10 cycles per second. Clear? But the actual unit of frequency, especially as, okay, when we talk about things such as waves, etc., whether it's sound waves, heat waves, electric waves, etc., is going to be hertz. Okay, so this frequency of a sound wave, which had actually is okay, 10 cycles per second, could also be expressed as 10 hertz. Okay, HERTZ, just like the rental truck company. Okay, or you may actually, as okay, may see that, okay, as the unit hertz is going to be abbreviated by HZ. Okay, capital H and lowercase Z as a zebra. So that's going to be as okay, the symbol for a hertz. Did you girls get that? Okay. Now, what we mainly as okay will be talking about as okay in ultrasound is going to be as okay multiples of hertz, whether that's going to be as okay multiplied by 10, 100, thousands, millions, or billions. Clear? So we're going to talk about as okay these conversions as okay later on today. But basically as okay a unit that we will hear a lot about, okay, is going to be as okay, or a kind of something that we will talk a lot about is going to be as okay a frequency, which means it's going to be as okay how frequently is it that okay as a certain event occurs in a certain period of time. That will be a frequency. Did that make sense? I just said that you had a quiz or a test because it's okay. One test. Oh, that's process. One test every 3 weeks. That's going to be as okay the frequency of your tests. That in a period of 3 weeks, you will have one test. Did that make sense? Okay. Now here, that's not going to be as okay 1/3 hertz. It's not going to be that. That is going to be as okay one test per 3 weeks. But especially as okay when we talk about things which occurs in waves, that frequency is going to be expressed as hertz. And what we are doing in ultrasound is we mainly as okay are going to be dealing primarily with sound waves. Okay, so how many sound waves or cycles are going to be completed in 1 second? That's going to be as okay the frequency of the sound wave, and that's going to be expressed in the unit of hertz. Okay, but we'll talk more in detail about it. Okay, frequency in chapter 3. And this is one of those things which is going to, as okay, be repeated again and again and again and again, just in different contexts. Okay, and when we talk about frequency, we will also, as okay, end up talking about its relationship to other parameters of sound waves. Okay, girls. Good. We said measurement, power, intensity, frequency, volume. We did mass, the distance, density, time, and area. Okay, good. Okay, girls. Let's do this. And we'll maybe as okay start talking about conversion of units. Okay, and the system that we will be using in ultrasound is mainly as okay what we call the MKS system. That's the official name. Yes, okay. People here, yes, okay, know it as the metric system. Okay. And conversion in the metric system is pretty much okay as very simple because it is mainly as okay going to be as okay multiples of tens, or we can say, okay, multiples of fractions of tens, or this actually also can be, because it's okay, dividing by tens. Okay. So it doesn't really matter which unit you are talking about, whether it's going to be a unit of distance, unit of mass, unit of frequency, unit or whatsoever. Okay, the conversion in metric system is pretty standard. And maybe it's okay just to clarify that standard. It's okay, we will check it's okay an x-axis. We can say here it's okay, this is our 0 point. Which mainly, that's what we mainly say is okay, what we're representing is okay, we're going to also get a basic unit. Clear? Now, if you guys remember yesterday, I mainly said that, okay, yes, this side here, that was the positive side. Whereas this side over here, that was the negative side. Right, okay. Where the negative side mainly would mean that these will be added as okay. We can say, okay, fractions of the now here's okay, basic unit, a whole number. Where okay, yes. Okay. Now fractions was mainly as okay, we wrote it like something like this, for instance, 1/1000 or 1/100 or 1/10, and so on. So, but this fraction here as okay can also be expressed as a decimal of the same basic unit. Where we say it's okay, decimal now, okay, if we said okay, yes, 1/1000, that can be written as a decimal form as 0.001. Their worth is the same. Is that clear? Okay. And one notation or type of notation that we actually is okay will be as okay coming across, which is going to frequently use is that okay, yes, this can also be as okay, we can say it's okay, written as an exponent form. Again, it's okay of the basic unit. Now here we say that 1/1000 or 0.001. That can also be as okay written as 10 raised to the power minus 3. And if you see here, that's why I said this side here was negative, because it's okay, your exponent is going to be negative. But all these three here is okay, have the same worth. 1/1000 is equal to 0.001, which is equal to anything is okay multiplied by 10 raised to the power minus 3. They all mean the same. Okay, now don't scratch your head and say, so Mike, what about 1/10,000? That's just going to be 0.0001. Or if you say here, like this. They all mean the same. Clear? Okay, now goes the units that we have. It goes deca, hecto, kilo, mega, and giga. Okay, whereas yes, okay, on the negative side is going to be deci, centi, milli, micro, and we can even just okay go and say nano. Okay, did that make sense? So that's mainly as okay going to be as okay your scale. Okay. Now we can just say yes, okay, any basic unit. It could be anyone. Let's just okay say that we have okay as a basic unit of distance. Meter. Now you may say decameter. Probably never going to be used, but what that actually will mean, or what deca actually will mean is multiply by 10. So you can say it's okay that 1 decameter is actually it's okay the same as 10 meters. Clear? Now, if you go hecto, actually means hundreds. So you can say it's okay 1 hectometer. Actually, it's going to be the same as saying 100 meters. If you go as okay 1 kilo, is actually 1,000. So you can say it's okay 1 kilometer. Is actually it's okay the same as is equal to 1,000 meters. Now mega goes that is actually it's okay going to be 1,000,000. And 1,000,000 is actually it's okay a 0 with 6 or a 1 with 6 zeros. Clear? Now in all these instances, okay, you can even go and say it's okay, this could also be written like this. 100 could also be written like this. So 1,000,000 is okay where you have 6 zeros. So instead of sitting there and counting the zeros, you could actually, it's okay, just write it as, or it could also be written as 10 raised to the power 6. Yeah. Okay. So you can say it's okay, 1 megameter. Now, probably not a unit that you will come across, but anyways, okay. Actually, so it's going to be as okay, you can see 1 million meters. Whereas a giga is mainly as okay, just going to be as okay a billion. And billion, that's mainly as okay 1 followed by 9 zeros. So you can see as okay, that's going to be easier just to write it like this. Did that make sense? But what is it that these exponents here means? Now, we did this yesterday and says, okay, 10 raised to the power 2. What does that mean? If we say it's okay, 10 raised to the power 2 or 10 squared, that mainly means 10 multiplied by 10, which gives you 100. Clear? When we say 10 raised to the power 3, what does that mainly mean? That mainly means this. That you multiply 10 by itself 3 times. So 10 times 10 is 100, times 10 is 1,000. Clear? So that 1,000 in the metric system is going to be used as, it's going to be referred to as a kilo. Similarly as okay, a mega. Okay, now just keep in mind goes that okay, as the symbol for kilo is going to be a K. The symbol for mega is going to be as okay, an uppercase M. Clear? But as okay, what was it? That was a million, which mainly as okay was. Maybe we're running out of room here. It says okay, a million, that was actually as okay, 1 followed by 6 zeros. Now these 6 zeros here could also be written as this, where the exponent may here mainly mean that okay, if you just multiply 10 by itself 6 times. So that's going to be just like this. Yeah. 6. So what do you have? 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000, times 10 is 1 million. Did that make sense? And so likewise, that's okay for a giga. Okay, whereas okay, the symbol for that means okay, just going to be as okay a capital G. Okay, which mainly is a billion. What is a billion? Mean is okay, 1 followed by 9 zeros. So that's mainly as okay what they did instead of okay, so you don't have to sit there and count the zeros. Okay, that's the mainly as okay, just wrote it as okay, 10 raised to the power 9, 10 raised to the power 6. You can even go as okay, 10 raised to the power 3. You can even go as okay, 10 raised to the power 2. Here is okay. It's really not worth it. It's okay writing 10 raised to the power 1. Because okay, it is not going to be multiplied by itself anyway. Did you ladies get that? So on the multiples, yes, okay, goes deca, hecto, kilo, mega, giga. Now just, so it's okay, you know, we're probably not going to, yes, okay, be dealing with gigas. We're probably not going to, yes, okay, be talking about hectos. Okay, we can mainly say as, okay, the 2 of the 3 units that we will be talking about here, most likely is going to be as, okay, mega and kilo, or that you will come across. Okay, girls? Okay. So this side here is, okay, these were all multiples of the basic unit. Okay. Now, if you go on to, yes, okay, the other side, and let's just, okay, we can say it's okay, there we have, okay, that's our basic unit here. Because we may need a little bit more room. So you can say, okay, here, this was our basic unit. Now, the first we had was deci. Then we have centi. The next is going to be going to have milli. Then we have micro. And then we have nano. Okay. Now, one thing goes, all these here were negatives, or we can mainly say, okay, I mean, because they are negative, that's mean as, okay, they make them, we can say, okay, fractions of the basic unit. Now, when we say fractions, that can also be, as, okay, be expressed as decimals. Now, why do you call a number a decimal? You may have a number, let's say, as, okay, 2.25. Or we can say is, okay, 2.25. This point here, that is actually as, okay, the decimal. So whatever is going to be as, okay, be written here, that's a whole number. Or as, okay, we can say on our scale, as, okay, was going to be as, okay, a multiple of our basic unit. Whereas whatever came after the decimal, which here, for instance, okay, was 2.5. This was the decimal number, which also is, okay, could have been expressed as a fraction. Did that make sense? Okay. Any questions so far? Now, girls, please make sure that you know the difference between this and, let's say, this. because it's okay if you just see a comma. Now, this may not be politically correct. Okay. That actually is okay, means 225. Or we could have put a 0 here. So that's okay. It could be 2,225. Here you can put not just 1 0, you can put a million zeros. They are going to be worth nothing. Because it's okay, your number is still just okay, just 2 comma or 2.25. But here it's okay, since you have a comma, this is still just okay, a whole number. It is only going to become a decimal once you put a full stop or a period. And then you can write, okay, yes, 25, for instance, or 50, or 28, or whatever. That'll be your decimal number. Okay. So here, yes, okay, we mainly, yes, okay, we'll be dealing with, okay, yes, decimal numbers, which are going to be, yes, okay, fraction or parts of, yes, okay, the whole number. Okay. Yeah, multiples of the whole number is going to be the same as multiples of the basic unit. Whereas the decimals, which means going to be, yes, okay, whatever comes after, yes, okay, the full stop, not the comma, will be expressed here. Okay. Now, when we say deci, that means, yes, okay, just mean that, okay, yes, that's going to be 1/10. 1/10 of what? 1/10 of any basic unit. So if we, as okay, as we just did earlier, said, okay, as we used meter. Now we can say, okay, 1 decimeter. 1 decimeter is going to be 1/10 of a meter. Yeah. Okay. So we can say it's okay. 1 decimeter actually is going to be equal to 1/10 of a meter. Okay. Clear? Now this 1/10 can also, as okay, be expressed and written in a decimal form as 0.1. So that mainly will mean that we can also write as, okay, 1 decimeter as being equal to 0.1 of a meter. Did that make sense? Or it can even, as okay, be written as an exponent form. Maybe again, as okay, you can say, okay, that this 1 decimeter, sorry, that this 1 decimeter here is okay, actually was going to be equal to, you can say, okay, 1 raised to the power minus 1 of a meter. Yeah. Where this raised to the power -1 here actually means that, okay, yes, it's equal to this, which is equal to this. So that's okay, that 1 raised to the power -1. All these here is okay, have the same worth. But just keep in mind, go that, okay, since you write it like this, then you're going to use, yes, okay, the unit meter. Because I was going to use, okay, the worth of 1 decimeter. So decis can mean, yes, okay, be written as this if we use the basic unit. Did you girls get that? Yes, girls. Please say yes or no.
Yes.
Yes. Because there are some girls who are sitting here who is taking this program over. And they may be able to tell you, yes, okay, what you expect. Out of the blue, randomly, yes, okay, you guys know brainstorms, right? All of a sudden you will be getting a brainstorm and I may ask, okay, so how many decis are there in a milli? And so on. So I will give you the cheats of how, yes, okay, how to do that, but get that answer. Okay. There's always, okay, the traditional way of doing it. And then there's the cheating way. Okay. So that's okay. Well, your tests are not going to be straightforward. You may calculate it out as 1 unit or 1 fraction or 1 multiple, but you may not find that direct answer. So you have to just, okay, convert the unit that you calculated into the right unit. And then you get our answer. Okay. So we're going to be sticking along with this as, okay, conversion for a little while. But if you guys get it, please let me know. If you don't, I don't mind explaining over again. Okay, girls? So that was your deci. So 1/10 of any basic unit is going to be a deci. Okay? People may understand, well, if you talk money. So you can say, okay, 1 $, that's a dime. Did that make sense? Clear? So if you take $1 and break it into 10 pieces, each piece is going to be as, okay, 1 $, or a dime. Why do people say, yes, okay, can I break this? When I worked at a pharmacy, sometimes some people will come and say, okay, can I break this $10 bill? And I say, let me try. Grab it and throw it on the counter. I say, well, it didn't break, so what do you want me to do now? But they'll say, okay, can I break it into dollars? Okay, so they mainly wanted to say, okay, yes, can I get $10 bills? Okay, so you can say, okay, $1 is a deci $10. But if you actually look at the word deci, what should come to your mind? Decade. That's the cheat. What's a decade?
10 years.
10 years. Okay, you actually saw that as okay, as on a deca. Okay, deca, decade. But deci is just on the other side. 1 cent. Clear? Now let's just go to the next one, girls. And what do we have is, we have a centi. Now centi, okay, I'm just going to use a different color, okay? Centi, that is actually, that's okay, going to be as okay 1 of 100. Now this is how you write 100 as a fraction. But as I told you, okay, anything that can be written as in a fraction can also be written in a decimal form. So that's just going to be as okay this. Oh, sorry. My mistake. One. Clear? And that centi can also be written as 10 raised to the power -2. And as I said earlier, I'm just going to repeat myself. That whenever you see as okay, this negative sign here is okay for an exponent, that will mainly mean that it is going to be as okay a fraction. Fraction of our basic unit. Yeah. So we mainly as okay, just come to the same and say as okay that 1 centimeter actually is okay was going to be equal to 1 of the 100 of a meter. Or it could be also be expressed as 0.01 meter. It's the same as 1 centimeter. Or if we go and say 1 multiplied by 10 raised to the power -2 of a meter. That is 1 centimeter. But if you look here, centi, the word centi or cent actually means 100. And just think of a century. But what would be a centimeter? Yes, okay. If we took a distance of 1 meter, now please, this is now 1 meter, and broke it down into 100 equal halves or parts, each of those would be 1 centimeter. But it's mainly as okay, just 100 of a meter. Or a centi of any basic unit means okay, that's going to be 100 of that unit. We just use meters here, but you can use any unit. You can use second, you can use watts, you can use whatsoever. Once you say centi, that basic unit, that becomes 100 of that basic unit. Okay. You can say centiliter, where centiliter is just going to be as, okay, 100 of a liter. Clear? So the only thing that you have to remember is, okay, as far as, okay, as conversion in the metric system is, what is a deci, what is a centi, what is a milli, what is a micro, what is a nano? And okay, on the other side, what's a deca, hecto, kilo, mega, giga. And after that, yes, okay, the conversion is straightforward. Okay, girls. Any questions about the centi?
No.
No. Everybody clear about the centi?
Yes.
Good. Thank you. Now a milli. Milli, yes, okay, that is just going to, yes, okay, be 1/1000. Okay, and that's a unit that we're going to, yes, okay, use a lot of. Okay, now 1/1000, yes, okay, that could also, yes, okay, be expressed as 0.001. Or in an exponent form, we can write it as 10 raised to the power -3. Clear? Okay. So if we actually, yes, okay, had that 1 meter, or that distance of 1 meter, and divided that into, yes, okay, 1,000 equal parts, each of those small fellows, yes, okay, will be 1 millimeter. But actually, it's okay, it's just going to be, it's okay, be 1,000 of a meter. Okay, now girls, please mind here, it's okay, that milli is also, it's okay, going to be expressed by the symbol m. But here is going to be a lowercase m. Why? Because the uppercase m has already been taken by, yes, okay, what we call the mega, which was 1 million times. Okay, or we could say it's okay, more correctly, it's okay, 10 raised to the power 6. Clear, girl? So yes, okay, you may, and we said that yesterday, we actually mentioned this yesterday, that we said 1 m for milli, and the other m for meter. Actually, yes, okay, was what we could say is okay, 1,000 of a meter. Clear? Or we could also say it's okay that it will be equal to 0.001 of a meter. Or even, yes, okay, 1 millimeter could also be written as 1 multiplied by 10 raised to the power -3. Now here you have to make sure that you don't write millimeter, but you actually say meter. Clear? Okay. But again, yes, okay, something that you gotta look out for, because if I wrote it like this, no, okay, that was a centimeter. Sorry. That was a centimeter. Sorry, my mistake. That was cubic centimeter, right? Okay. But again, yes, okay, if you write it like this, it wasn't a unit of distance anymore. It became a unit of volume. If you, for instance, okay, squared any of these, then it became area, right? Right? So 1 millimeter, 1,000 of a meter. And okay, I just think here is okay, and a cheat for this one here is okay, was again is okay, what we call the it's okay. Millennium. So we had decades, we had centuries, and then we had millenniums. Okay. Now, some of you might not even be born when, okay, yes, we went into, yes, okay, the new millennium. Right, okay. Who is not mute? Okay, goals. But what was that? Not just a decade, not just a century, but as okay, we went from the 1900s into the 2000s. Okay. But just remember, go that okay, as milli is 1,000. And that's going to be as okay, a unit that we, or a conversion that we will have a lot of. Clear? And just remember that okay, as millimeter is going to be as okay, or any milli is going to be as okay, a lowercase m. Okay, you can say it's okay, millimeter, then that's just going to be mm. You can say milli. Okay, damn it. For instance, second. Now, some people may write, okay, m as milli and sec for second. Some people, yes, okay, may just write ms. Where m is still the same, milli, and second is, and s is for second. So what's 1 millisecond going to be? What's going to be time of 1 millisecond? Anybody goes? If 1 millimeter is the thousandth of a meter, if 1 milliliter is the thousandth of a liter, if 1 milligram is the thousandth of a gram, then 1 millisecond is going to be what?
1,000th of a second?
Exactly. Yeah. So it's very straightforward, girls. Clear? Okay. You may see that in the Olympics. When there's, okay, as who crossed the finish line first. And it may be that, okay, as the guy or the whoever is, okay, determined to be as, okay, the winner. cross the finish line by, okay, yes, 2 milliseconds ahead of the runner-up. Okay, so that clock that goes, yes, okay, you can't even, that's okay, all along, because, okay, all along is a second. And then you split that into, yes, okay, 1,000 apart. Forget about that. Right, okay? But that may be, yes, okay, that point of difference that, okay, yes, determines. So, yes, okay. Okay. So you may see a number that go 1, 2, 3, 4, and after that, it's okay, that's a decimal, and the number that changes even faster and faster, the longer the number gets. Because the longer away you get from the decimal point, the smaller is it that the fraction becomes. Because you say that's okay, 1 decimal point, that's a deci. That's where the word decimal comes from deci. 2 decimal points, a centi. 3 decimal points, a milli. Clear? Now you can say it's okay. 6 decimal points is going to be the next one, which is going to be okay, a micro. And micro, it's okay, is just going to be the opposite of a mega, which is going to be as okay, where mega was okay as 1 millionth or 1 million. This is going to be as okay. A micro is going to be as okay, 1 over a million. So 1, 2, 3, 4, 5, 6. Right? Okay. Now that could also be written as this. Like this. And this is really where I say it's okay, like, okay, let's not sit here as okay, I count the zeros. So usually as okay, you will be getting it like, okay, as 10 raised to the power minus 6. But again, as okay, as I had said in the deci, in the centi, in the micro, and the milli, and I'm going to say now as okay again in the macro. That is okay. Once you see a negative against the exponent, that may mean that okay, as this is a fraction of the basic unit or a decimal of the basic unit. Clear? Did that make sense? Now goes for the micro. The micro is okay, that may as okay be expressed by 2 symbols. Some people may express it where okay as MC. Okay. Or you may actually see as okay, see it be expressed by this symbol here, which is a mu. Okay, so this is going to be as okay, the symbol of micro. So if you said, for instance, okay, micro meter, you could said, or you could have said micro. Now again, as okay, some people may go for front that says okay, second, or they may just say okay as S or second. But again, yes, okay, you can also go and say micro liter. So what is a microliter, or what is a micrometer, or what is a microsecond? Mean is okay, just 1/1,000,000th of that unit. Yes, my dear.
So what would be their symbol? Is it that capital M or no?
No, it's not going to be a capital M. It has this symbol here, and it actually is going to, yes, okay. It's written something like this. Or you may see, yes, okay, like something like this. You will find it in your book on page 6, table number 1.2. Do you see where it says mega and micro?
Yes, I see it. Thank you.
So mega is the symbol for, that's okay, the symbol for mega is going to be a capital M. The symbol for micro is MU. Or some people may even, yes, okay, write micro as okay by MC. But scientifically, yes, okay, or scientifically speaking, yes, okay, it's going to, yes, okay, be represented by this weird symbol here. It's not really as okay written as an M. It's not really written as a U either. It's a, you can say, a mixture of the both. And they call it mu. Okay, so the name of this symbol here is mu. Okay, but it represents micro. So I said, we say, yes, okay, the symbol for meter is M. The symbol for liter is L. The symbol for hertz was just at Z. Clear? Okay. So that's okay. Simple or abbreviation, if you want to put it that way. Clear? Okay. For centi, the symbol for centi was simply a C. Sample for deci is okay as a lowercase d. Clear? The sample for milli is mainly as okay, just a lowercase m. The symbol for micro is either MC, or to be more correctly, as okay, the symbol will be as okay, mu, which is this, something that looks like this. Not an uppercase M. Okay, sometimes you may even see it's okay, it being written like this. Did you guys get that? But what is a micro? It's going to be, it's okay, 1/1,000,000th. Clear? Okay, you write 1,000,000 as a fraction, 1/1,000,000. As a decimal, 0.000001. Clear? Or more correctly, as okay, as an exponent, 10 raised to the power -6. So this 6 here, what does this 6 here as okay as the exponent means? Million. Whereas the minus mainly is okay mean that we are talking about is okay a million fraction. So okay, the minus actually is okay makes it a millionth. Clear? Just like here is okay. Here the 3 mainly is okay tells you 1,000 or 1,000. But the minus makes it a 1,000, which makes it a fraction, right? Here, 2, the exponent 2 is 100. But since it is expressed with a negative sign, it becomes 100. Where the, and even here is okay, 10th. Or 1/10.
I have a question.
Yes, my dear.
So like when the exponent is negative, is it always a fraction?
Yes.
Yeah, okay.
And just keep in mind, okay, as a fraction can always be as like expressed as a decimal as well. Fraction is just writing it like, okay, something like this. Or this, or this. This is fraction. Clear? But you
Yeah.
can also write this as a decimal, which could be as, okay, this. Or it can also be written with, okay, as an exponent, which is going to be then this. Yeah, the negative sign here is okay, meaning it's okay, indicate that it is a fraction.
Okay. Thank
Did
you.
that make sense?
Yeah.
Right, okay. That's why I say it's okay. On or is okay, line off is okay. Or this integral line, that's what they call it. Right, okay. That, okay, yes, in the middle you have 0. On this side you go on, okay, it just becomes multiples. On this side here, it's okay, it's just going to be as okay, fractions of the basic unit. Fractions can also be expressed as decimals. And just like the multiples can also be expressed with exponents. Did you girls get that?
Yeah.
Yeah.
Or if you just say that, okay, this is a timeline. Okay, if we say that, okay, this whole thing here is okay, it was a timeline. This is year 0. So what we mainly have here is going to be, it's okay, AD. This is where we are now, right? Okay, we are in 2023 AD. What came before year 0 is what we call BC. Clear? Did that make sense? Okay, now here we don't say it's okay, minus 2,000 years or something. We may as okay, what I just have said, okay, as 2,000 years BC. Which makes it okay, 4,023 years ago. Did that make sense? If you talk about an event that happened, let's say it's okay at 3,000 BC, that's going to have been as okay 5,023 years ago. Clear? But okay, here on our exponent line, is okay, sorry, on the integral line, what do we call all things? Yes, okay, that's going to be yes, okay. AD. That's going to be positive exponents, which mean okay, these are going to be multiples of the basic unit. Whereas anything which is going to be as okay on this side here is going to be negative. Exponents. Okay, and negative exponents is mainly going to be either expressed as fractions or decimals. Of what? Of whatever it has as our basic unit. Did that make sense? Okay. But yes, okay, the conversion is very straightforward, my girls. Okay. So micro of any unit is just going to be a basic unit. Please keep that in mind. So you can say, okay, micrometer is 1/1,000,000th of a meter. Microsecond is 1/1,000,000th of a second. Clear? Did that make sense?
Yes.
Okay, so you can write, for instance, you can say, okay, 1 micrometer. Now that's actually, that's okay, going to be equal to, that's okay, we can say, sorry, 1 raised to the power minus 10, 6 of a meter. Practically, these have the same worth. Or if you're not satisfied writing it this way, you can also write it and say, okay, that's going to be equal to 0.0000 meters. Or if you don't like it this way, you can still write, okay, that 1 micrometer is going to be equal to 108.224.56 meter. They all mean the same. Here goes. Now, nano. Let's just take that to normal. That's fine. So it's okay because it's okay. Nano. NaNO. It's actually, it's okay, 1 billionth. Which means you mean that, okay, and as I said, this here is okay, mean is okay, just makes it a fraction of the basics. Now, this 1 billion here can also be written as 0.224. Yeah, shoot. Like this. Or 1 over like this. And you really don't want to sit here and say, okay, count the zeros. So that's why you can actually say it's okay, 10 raised to the power -9. And then you can put any unit, you can say it's okay. Nanometer, 1,000 of or 1/1000th of a meter. You can say it's okay, nanosecond, 1/1000th of a second. Good luck counting that one. Okay, okay. You can say nanoliter is okay, 1/1000th of a liter. A milliliter is small, a microliter is even smaller, and a nano is even a drop is going to be as okay, a single drop is going to be as okay, bigger than okay as a nanoliter. So even a drop of as okay, any liquid is not going to be as okay 1 nanoliter. But there are things that actually as okay are measured in nanos, which mean okay, they are pretty small. Okay. Did that make sense? Now, there was a mnemonic that somebody as okay came up with of the yes okay, or we can call yes okay the units in a decreasing order. And okay, goes when I say yes okay in a decreasing order, that mainly yes okay means that so okay that mainly means okay as you start from bigger to smaller. Okay, now the mnemonic yes okay didn't really yes okay mention all of the units that we have. We can mean it says okay here that okay as we cross from bigger to small, we will come across the basic. Or we can mean it's okay, just say it's okay the unit itself. Where we can say it's okay. It is great. Master. King. Henry. Now, if somebody doesn't like King Henry, they can choose any other name as long as it starts with an H. You can say Harry. He probably may not become king, but anyways. Okay. Doesn't. And then we can just say it's okay. Usually. And now we just go fractions. Drink. Chocolate. Milk. And who gives the milk something that says moo? Anyway, usually don't drink chocolate milk. You're going, nah. Okay. So what is this? Giga. Mega. Kilo. Hecto. Deca. U for unit. Then we go deci. Centi. Milli. Mu is okay for micro. And na for nano. Okay. Now, if you guys don't like this mnemonic here, you can make up your own. It doesn't really matter. You say, okay, I don't want mnemonics. I just go, yes, okay. Remember, from greater to smaller, giga, mega, kilo, hecto, deca. Then unit, then deci, centi, milli, micro, nano. Clear? Just remember that, okay, as giga is billion, mega is million, kilo is 1,000, 100, deca 10, deci. Now these are all fractions. So I'll just write them as fractions, which will be as, okay, 1 hour, 1 hour, 1 hour, 1 hour. And 100, 1,000, sorry. Million, and okay, yes, billion. Or we can say 10 raised to the power 9, 10 raised to the power 6, 10 raised to the power 3, 10 raised to the power 2, 10 raised to the power 1, which is just 10. So the same here becomes 10 raised to the power minus 1, minus 2, minus 3, minus, sorry, no, 4, sorry, minus 6, and minus 9. Did that make any sense?
Yes.
Okay. Who didn't get it? Who didn't get it? Okay, girls. Now just take a short break. Get your coffee. Some of you look pretty sleepy. Okay. And now when we come back, I will tell you girls that's okay how we convert from one unit to another. And vice versa. From bigger units to smaller units, and from smaller units to bigger units. What will be the rule? Yes, okay, if we don't cross the zero line. And what will be the rule? Yes, okay, when we cross the zero line. Okay. So yes, okay, get your mathematical genes out. Or else, okay, wake them up. Because, okay, we may be needing those. Okay, guys? So should I see you guys at, should we say, 11:45? Is that fair enough?
Yeah.
Okay. Have fun till then. Welcome back, girls. Now, before I try to continue, any questions at this point, girls? No? So you guys are clear about the units? Okay, let's see. Yep. And we said, Becca, Hector, Kilo, Mega, and Giga. Clear? Whereas, okay, on the other hand, we said, deci, centi, milli, micro, and nano. Okay. We said that this one here was 10 raised to the power -9. We said this was 10 raised to the power -6. We said this was 10 raised to the power -3, -2, and okay, yes, we can do it like this. And this was 10 raised to the power 1, 2, 3, simple 6, and 9. Did you guys get that? Right? Okay. Now, what we mainly can say is if you want to convert from a bigger unit, right? Okay, to determine its value using a smaller unit. You will multiply by the difference of the exponents. Now, girls, look here. Let's say that we have a bigger unit. Let's say that we go and say kilometer, right? Did that make sense? Okay. And we want to just, okay, find the worth. Let's say it's okay that we said, okay, just to be simple, 1 kilometer. Now this 1 kilometer here is okay, can also be written as 1 multiplied by 10 raised to the power 3 meters. Clear? Now kilometer is okay because it's okay in this context here is okay, that's going to be as okay the bigger unit. But if you want to say, okay, now how many decameters do we have in 1 kilometer? Okay, so this 1 kilometer, that is actually now going to be equal to, and we can say, okay, now deca, the symbol for that was going to be E. And okay, we can say it's okay, meter is going to be, yes, okay. Meter. Right. Now, what is the exponent here? Wait. What is the exponent here? 2. 1, sorry. So what is going to be as okay, 3 minus 1 is going to be equal to 2. That will mainly mean that, okay, yes, the exponent is going to be, yes, okay, this. So we can actually say that, okay, as 1 decameter, oh, sorry, 1 kilometer actually is going to be equal to 1 raised multiplied by 10 raised to the power 2 decameters. Where this 10 raised to the power 2 here actually is, that's another way of writing 100, right? Did that make sense? So what did we do? Yes, okay, we mean yes, okay, just multiplied by the difference of the exponents. Okay, goals? But that was when we, yes, okay, want to, yes, okay, determine the worth of a bigger unit being expressed in a smaller unit. Okay, because you can actually say that this 1 multiplied by 10 raised to the power 2, by 10 raised to the power 2 actually, yes, okay, means 100. It's going to be saying 1 multiplied by 100. That's okay, decameter. And what is 1 multiplied by 100 going to be? 1 multiplied by 100 is going to be what? Yes, goals.
100.
100, exactly. Very good, my dear. Okay, so 1 kilometer is actually the same as 100 decameters. Okay, where decameter means, yes, okay, was just 10 meters. Did that make sense? But that's how we got that. We can even, yes, okay, say, yes, okay, if we go and said, oh, let's choose another color. We say, I can say it's okay, megameter. If you just want to do that. Clear? And we want to say, well, okay, how many decameters are there going to be as okay in 1 decameter or 1 megameter? So we can say, okay, 1 megameter, or more correctly. Okay, now here, this mega, what was the exponent for that? 10 raised to the power 6. But we want to just, okay, find its worth in decameters. Now it's okay, the deca was 10 raised to the power minus, or 10 raised to the power 10, or 1, sorry. Clear? Okay. So now it's made as okay, that's going to be as okay, what is the difference between 6 minus 1? It's 5. So we can actually say that, okay, yes, 1 multiplied by 10 raised to the power 5 decameters is the same as 1 megameter. Where megameter means it's okay, there's going to be, it's okay, 1 million meters. Where this 10 raised to the power 5 here mainly just means nothing but is going to be, it's okay, 100,000. So you can actually say it's okay, 100,000 decameters is going to be, it's okay, 1 megameter. Or 100,000 decas is going to be a million, is going to be a mega. Did that make sense? If you go and say it's okay, anything in gigas being expressed in micro in decas. Well, okay, we just do the very same thing. You mean it's okay, we'll just multiply by it's okay, the difference of the exponents. Where okay, for deca it is 1 raised to the power minus, or 1 raised to the power 1, or 10 raised to the power 1, sorry. Where okay, as for the giga, it is 10 raised to the power 9. So it means okay, we just multiply by 10 by the difference of the exponents here, which is going to be as okay, 10 minus 1. Oh, sorry, 9 minus 1, sorry. Well, it's going to, this is messy now, sorry. Okay, 9 minus 1, which is going to be 8. Which means that okay, as 1 deca of anything is going to be equal to, oh sorry, 1 mega, sorry, of anything is going to be equal to 1 multiplied by 10 raised to the power 8 deca. And then it doesn't really matter if, okay, you can put any unit here. You can say meter, you can say second, you can say hertz, you can say whatever.
I have a question.
Mhm.
I'm getting kind of lost with the mega, because
Yes, but what about the mega?
didn't you just say something about the mega? Because I'm following all the way, from the giga and the deca. But
No, sorry, no, sorry, giga, sorry. Yeah, this was a giga, sorry.
okay, thank you.
Because for mega, yes, okay. Okay, but it's the same. You can mainly say, okay, go and say, okay, and okay, I may just erase this for a second. Because you can say it's the same concept. You want to say as okay, the concept is the same, okay, dear? You want to say as okay, how many kilos are there in a mega? Okay. Or we can say, okay, we had, okay, as something expressed in mega. Let's just say it's okay, for instance, megahertz. Let's say that we had 1 megahertz. This 1 megahertz can also yes, okay, be written as 10 raised to the power 6 hertz. Clear? But what you actually is okay want to determine, how can this 1 megahertz be expressed using the unit kilohertz? Where kilo now is mean is okay, just going to be as okay 10 raised to the power 3. So the way that you actually is okay will be able to yes, okay, do so is that you can say, okay, what is the difference between mega and kilo? That mainly is okay what you will need to yes, okay, determine. So yes, okay, the exponent for your mega, or you can say the mega that was 10 raised to the power 6. The exponent for your kilo was 10 raised to the power 3. So we mainly as okay, just going to as okay, multiply 10 by as okay, the difference of the exponents here. Where you say that difference will be 6 minus 3. And what do you get from that? 3. So you will actually be able to see that will mainly mean that, okay, yes, 1 megahertz. It's actually going to be the same as saying 1,000, because here this 10 raised to the power 3 itself also become 1,000 kilohertz, which is 1,000 hertz.
Can you go over it one more time, please?
No problem there. Do you guys mind if I go to another slide? So it doesn't get that crowded? We can say, okay, basic, and we say it's okay. Now what was, let's go, we can see. Giga. Okay, what was a giga? 10 raised to the power 9. We can go mega. What was that? 10 raised to the power 6. Clear? What was the next one?
Kilo.
Kilo. 10 raised to the power 3, right?
Yeah.
What was the next one? Hecto. Sorry. Okay. Now what was that? 10 raised to the power 2. Now what was the next one?
Deci.
Deca.
Deca.
Deci was on the fraction side. Okay, yeah.
Oh, okay.
So that was 10 raised to the power 1, or mainly it's okay, just 10. Because what was it that these exponents here means? The time that you multiply 10 by itself. And that's why I say it's okay, the metric system is mainly as okay, either just fractions of tens or multiples of tens. Did that make sense?
Yeah.
Right, okay. Now, if we find, okay, let's just, okay, as here is okay, use parts as a unit. Clear? Now, if you, for instance, said that we have, it can be any number. Okay. Let's just say that we have 1 giga hertz. Clear?
Yeah,
Did that make sense?
yeah,
Okay. Now, what we actually is okay, you are given, okay, I say, okay, you have 1 gigahertz. But you may be asked, what is the worth? Or how are you going to express this gigahertz using the unit kilohertz? Did that make sense?
yeah.
Right. Okay. Now, what you will need to do is, first of all, yes, okay, see, well, okay, what is the difference? Now, what is the exponent for kilo? 10 raised to the power 3. What is the exponent for giga?
10 raised to the power 9.
10 raised to the power 9. Okay. Now, please keep in mind here, yes, okay, that you are given, yes, okay, something expressed in a bigger unit. And you want to, yes, okay, find its worth or its equivalent using or being expressed in a smaller unit. So what we mainly, as okay, need to do is, well, like I say, first of all, what was the difference between giga's exponent and kilo's exponent? That's mainly as okay, the cheat. So that's going to be 10 minus 3. So what do you get from that, my dear?
6.
6. So now you can actually say, okay, mainly as okay, just say the now. Okay. 1. Kilohertz. Is equal to, no, sorry. Okay. This is going to be as okay, unit. 1 is 1, 1 is 1. Okay, but here's okay, was giga, you want to express its word using the unit kilohertz. So that will mainly mean that, okay, as you will need to multiply it by 10 raised to the power 6. Did that make sense?
Yeah.
So you can actually say that, okay, there's going to be, okay, be 1 million. Because what do we know that 10 raised to the power 6 actually is, okay, stands for? A million, right?
Yeah.
So that's actually going to be 1 million kilohertz, where this kilo here itself was 1,000. Is going to make up 1 gigahertz. Did that make sense?
Yeah.
Clear? If you don't want to go as far as a giga, and you want to say, okay, I just want you to, okay, find the worth of megahertz. But still expressing it in in terms of kilohertz. That concept, my idea, is still the same. Or we can say, as okay, the cheat is still going to be the same. Because, okay, a mega's just, okay, exponent was, or we can say, okay, it was 10 raised to the power 6. For the kilo, yes, okay, it is still 10 raised to the power 3. So what do we need to do now?
Subtract the exponent.
Subtract exponents. Okay, so you say 6 minus 3. So what do you have now?
3.
3. So now you can actually say that, okay, as 1 megahertz is going to be equal to, Marcus, okay, 1 is 1. Now, 10 raised to the power 3 kilohertz. Or you can actually say it's okay that 1 megahertz is actually going to be equal to 1,000 kilohertz. Did that make sense?
Yeah.
Good. Any questions? Now, this was when you went from, yes, okay, from a bigger unit to a smaller unit. Or you can say, okay, express its worth in a smaller unit. Clear? Okay. The unit gets smaller, but the number gets bigger. And yes, okay, just like you chalk money. Right, okay, because you say it's okay, $1 bill. Now let's just say it's okay, a dollar bill is a big unit. Clear? But when we go to a smaller unit, like say dimes, the number becomes bigger, right? The number is now 1, now it becomes 10. Did that make sense?
Yeah.
How did you get that? Because it's okay, there are $10 or 10 dimes in a dollar. Okay, there are 10 dimes in a dollar. Okay, but even if you went even smaller and say as okay, $1, cents or pennies. Now that unit become even smaller, right? Because okay, a cent or a penny is smaller than a dime. But then you see the number becomes bigger because for dimes it was just 10. For pennies or cents is going to be 100. Did that make sense?
Yeah.
Right, okay. So the number will become bigger as the unit gets smaller. When you express, but that's okay. When you put them side by side, that's okay. I got 10 dimes, I got a dollar bill. They're worth the same, right? Okay. I got 100 pennies, I got 10 dimes, and I got a dollar bill. They're all worth the same. Okay, now the penny is a smaller unit. The dime is a bigger unit, and of course, that's okay, the dollar is a bigger unit. Did that make sense?
Yeah.
Okay, but then you can say it's okay, $10, then how many dimes will you need now? Now you will need 100 dimes. Right, okay, okay. And 100 dimes you will need, yes, okay, 1,000 pennies. Did that make sense? Okay. So yes, okay, the bigger unit gets, the bigger will be the number for the smaller unit. Okay. Did that make any sense?
Yes, it did.
Okay. Anybody who didn't get it? Girls, don't look so depressed. Okay. Now you then may ask me, Mike, what if we go the opposite way? What if we, for instance, said, let me just erase all this, not all of it, just this. What if we said, for instance, yes, okay, 1 kilo hertz. Right, okay. And we actually, yes, okay, want to, yes, okay, know its worth. And let's say it's okay. Let's just go to this one here first. Sorry. Mega. Right, okay. Now goes, the first part here is still going to be the same. That we still, yes, okay, we need to, yes, okay, fine, yes, okay, what was the difference between, yes, okay, a kilo? It was 10 raised to the power 3. And let's say it's okay, a mega, which was 10 raised to the power 6. Clear? So we're still going to say as okay, what is the difference between these two exponents here? Is there going to be as okay, 6 minus 3, and we'll get 3. But the thing is going to change now, mainly because, okay, we are having something, yes, okay, in a smaller unit, or expressed in a smaller unit, and we want to find its worth, or its value being expressed in a bigger unit. So here, yes, okay, it is the same statement as I wrote before. But here you can mean it says, okay, if you want to convert from a smaller unit to determine its value using a bigger unit, you will now multiply. Well, we can say you will either multiply or you will divide by the difference of the exponents. So what would that mean? Now here is okay, you have 3 that became, yes, okay, the difference. Clear? Okay. Now when we will multiply it by a fraction, now we say it's okay, 10 raised to the power 3, that was actually, it's okay, what we're going to see. Or we is okay, 1 over 1,000. Clear? This could also is okay, we could also is okay, you will multiply by, or it will be the same as saying it's okay, multiply by 0.001. Clear? Or it will be the same as saying it's okay, dividing it by 1,000. And what did that mean? Now, since it is going to, it's okay, we multiply by a fraction. What would that be? It will become z minus 3 in this case here. So we can actually say that, okay, as 1 kilowatt is equal to 1 multiplied by 10 raised to the power minus 3 megahertz. But okay, as this 10 raised to the power minus 3 here actually means 1,000 of a megahertz. Did that make sense?
Can you go over it one more time?
That you mainly is okay, just will multiply it by the fractions or divided by 1,000. What do you get then? Now this is going to be as okay. You can say it's okay. 1 multiplied by 10 raised to the power minus 3. Now what does 10 multiply or 10 raised to the power minus 3 mean? This actually means 1 over 1,000, right? Right?
Yes.
That's why okay, if we expressed it as a fraction. We could also say it's okay, this could also be it's okay 0.001. Clear? So that's when we as okay either multiplied. Or you can say it's okay that you can actually it's okay divide it by 1,000. Because multiplying any number by 1 over 1,000 is the same as dividing it by 1,000. Okay. So what we actually is okay get from this is that 1 kilohertz is equal to 1,000th of a megahertz. Did that make sense?
So -3, like does it always have to be a negative, the exponent, when you're going from low to high?
Yeah, because now your number becomes smaller. This 10 raised to the power minus 3 actually means 0.001.
Okay.
1,000th. How do we get that? Main is okay because using the cheat here, right?
Yeah.
Clear? Okay. But that only applies as okay when you go from a, it's okay. We said we had 1 kilohertz, which was a smaller unit. And we want to express its worth using a bigger unit. So it's the same concept, girls. Just the opposite way now. You have 1 penny. And you ask somebody, well, give me the worth of $1 bill for this penny. What would he do? He will rip that 100 or he will rip that dollar bill into 100 equal parts and give you 1 part. That's okay. This is what you get for your penny. Now you can bring back 99 more pennies and okay, let's get the other 99 parts. And then that's okay. Stick them together. But your that 1 penny was actually as okay worth what?
0.001.
No,
No? Oh, sorry.
0.01 of a dollar, right?
Oh, oh,
The 100th of a dollar, right?
yeah.
Are
Did
you
that make
able,
sense?
sorry, are you able to do like another example?
I don't mind. Which one do you want to convert from? To what?
I don't know.
You don't know? Well, okay.
How about we do deci to kilo?
Now, at that point, give them idea goal, just okay, we will have to cross the 0 line.
Oh,
Then it
okay.
will be a little bit different.
Then hecto or hecto, or however you say that word.
Hecto to what?
To mega, maybe.
Okay, no more problem there. It's the same. Okay. Okay, let's just erase a little bit here. It's all just determined as, okay, what is the worth? Okay, so we wanted to go from, and we says, okay, 1. Okay, good. One hectohertz. And we want to express its worth in, which one was it? Megas?
Yeah.
Okay, good, no problem. Yeah. So we said, okay, we had 1 hectohertz. What does this hectohertz means? Hecto is 100, right? 100 can be written like this, or it can be written as 10 raised to the power 2, right? What was mega? 1 million or 10 raised to the power 6. Did that make sense? Clear? Now we made it, okay, just need to say, well, okay, what do we need to do? We say it's okay, 6 minus 2. What do we get? We get a total of 4. So that will mean that, okay, as 1 hectohertz is actually going to be equal to. Now goes here, it's okay, that's me, it's okay, it's because we go from a bigger unit, or from expressing as, okay, the worth of a smaller unit being expressed in a bigger unit. So we actually do it, that will become, says, okay, 1 is now going to be as, okay, multiplied by 10 raised to the power minus 4. Mega. So what can we actually say? Now this 10 raised to the power minus 4 actually is okay. Oh, it's actually going to be the same as saying, sorry, 1 over 10,000. Did that make sense? So once you go from a bigger unit, from a smaller unit, to express its worth in a bigger unit, the number becomes smaller. Because now here this 1 multiplied by 10 raised to the power minus 4 actually means 1 divided by 10,000. Did that make sense? So 1 hectohertz is equal to 1/10,000 of a megahertz. Okay. So actually saying it's okay, multiplying by, in this case like this, is going to be equal as saying multiplying by 1/10,000 or multiplying by 0.0001. Or actually it's okay, it can be the same as dividing by 10,000. Did you guys get that? More and more people are now looking depressed. What did we get ourselves into? But just look at that, okay, just look back at the currency example. That's the easiest way to, it's okay to remember the cheat. All right, okay. Then when you go from a smaller unit, expressing its worth in a bigger unit, the number will get smaller. Now, all of a sudden, yes, okay, once you start talking fractions, it's going to be a smaller unit, right? Or you can even look at a cake. Either you eat the whole cake yourself, or you just get, okay, as one small corner of the cake because there's, okay, as another 999 people who wants to eat the same cake. Or if there's 10,000 people to eat that same cake, it's okay, they will even get a smaller piece, right? Not to talk if there's 1 million people invited to the party and it's the same size cake, you get even a smaller piece. Did that make sense? Okay. So where the cake mainly is, okay, what you are given as a unit or as a, okay, as number or value or whatever. So the difference is mainly as, okay, if you go from a bigger unit to a smaller unit, you can express the worth of, okay, as a value given and expressed given in a bigger unit. To find its worth in a small, it's okay being expressed in a smaller unit. You will multiply. Multiply by what? by the difference of the exponents, or 10 raised to the power of the difference of the exponents. There is going to be the opposite side when you go, it's going to be opposite or reciprocal when you go from as like expressing something in its given in a smaller unit being expressed and express its worth in a bigger unit. Because if we said 1,000 or if we said 1 megahertz, if we just go the other way around and we said, okay, we had something being expressed as, let me just write it over here. There we said, okay, as one megahertz. Maybe this will help you. And we just want you as, okay, express the worth of this in hecto. Sorry. Hertz. We said we have 1 megahertz, but we want to find its worth in hectohertz. Now this part here is still the same. You say, okay, hecto is this, mega is this. Right, girls? We still do the same. Subtract 2 from 6. And what do we get? We get 4. Here we just go as, okay, 1 is 1. But now we mean it's okay, we'll just mainly it's okay. Multiply by 4. And okay, yes. You have hecto hertz is the same as 1 megahertz, which mainly or actually means that okay, it becomes 1 is 1. And this 10 raised to the power 4 here actually is okay, will become 4 zeros, which is the same as saying 10,000. Hectohertz is 1 megahertz. Whereas if we went the opposite way and say, and did what we did here, or did before, okay? And says, okay, we had 1 megahertz or 1 hectohertz. What is going to be its worth in megahertz is going to be 1 of a 10,000 of a megahertz. Did that make sense? So you can say it's okay when you go from a bigger unit expressing its worth in a smaller unit, you will end up with a bigger number. Because 10,000 is bigger than 1 of a 10,000. Did that make sense? Whereas if you go the other way around, let's say it's okay, you have a smaller unit and you want to express its worth in a bigger unit, using a bigger unit, you would end up with a fraction. because a smaller unit is always going to be as okay, smaller than a bigger unit. Yes, girls. Any questions? So it really doesn't matter, girls. It really doesn't matter which one you want to convert from. But just remember that, okay, yes, you're given something in a smaller unit and asked to express its worth in a bigger unit. You will end up with a smaller number or a fraction or a decimal. Right, okay. How big or small that fraction is going to be. That is going to, yes, okay, be determined by calculating or subtracting the difference of the exponents for the unit that you use. Whereas if you have something being expressed in, okay, as bigger units, but are asked to, yes, okay, find its worth being expressed in, okay, as a small, using a smaller unit. You mean is, okay, just you end up with a bigger number because, okay, because it's a smaller unit. I mean, it's okay because it's okay for here, it's okay, you multiply in this conversion. In this conversion, it's okay, when we said we had 1 hectohertz, you will divide. Divide by what? That's okay. The difference between, yes, okay, same difference between, yes, okay, the two exponents, or yes, okay, it's okay, tan of the difference. Over here, it's going to be, yes, okay, it is going to be a negative exponent because you go from a bigger, smaller unit to express it as it's worth in a bigger unit. Now just think upon this one a little bit, or in between every bite of your meal. Okay. And yes, okay, girls, when we come back, we can, yes, okay, see if we can, yes, okay, cross the basic unit line and see what the trick is there. There's a slight difference, but okay. It still comes back to the same. Right. So whatever meal you prepare or have prepared for yourself, just say, well, okay, right now it's me and me alone. You eat the whole. But if I had 5 people invited over, how much would they get? Then, okay, if it was 10 people who came over, how much would they get? Or if I had invited 1,000 people, how much would they get? Clear? Or then you can say, it's okay, if I have 1,000 people invited over, and I want everybody to have, it's okay, the same amount of meal that I'm eating now. How many sandwiches or whatever you are preparing, bowls of soup or chicken patties or whatever would I be making? And you will see the logic here. Okay. So would it be fair enough to see that I'll say that I see you girls back at 12:45? Now just make sure that you masticate your food before you deglutitate it. Yep. So have fun, girls. Welcome back, girls. Okay. So does anybody have any questions at this moment? Yes,
I
my dear.
do.
Go ahead, my dear.
So, when converting from, a lower number to a higher, like a deca to a mega, it's always gonna be negative because it's a smaller, or is that? it's
Exactly.
always gonna
You will
be
end up with a fraction of what you started.
Yeah, okay,
Like the number is going to be a fraction. Okay.
okay,
Because you expressing its worth in a bigger, yes, okay, using a bigger unit.
okay.
Clear?
And it's not going to be that way from a bigger unit to a smaller unit.
No, then it will be a bigger number. The number will be bigger, but because the unit is smaller.
Okay,
Okay. Okay. So just like we said, okay, $1 is a small number, right? Clear? Because we can say, okay, dollar is a bigger unit. Clear? But then you go as, okay, pennies. The number is going to be bigger because the unit is smaller. Clear? Did that make sense? Right, okay. So it is actually, yes, okay, that's that we say that, okay, yes. If we do it this way, I say, yes, okay. $1 is equal to, let's say, this many cents. Clear? Now that will mainly mean that, okay, yes, you would end up with 100 cents. Now here you see, ladies, when you compare the number 1 and 100, this is a smaller number, whereas 100 is a greater number, right? Why? Because the dollar is a bigger unit and cents is a smaller unit. Clear? Now, say we said, okay, as $1 is equal to 100 cents, that will mainly mean that, okay, as then the worth of 1 cent is going to be as, okay, 1/100th of a dollar. Did that make sense? And we can even say, okay, this $1, these 100 cents is going to be equal to 10 times. Now here, yes, okay, when comparing, yes, okay, dimes and dollars, we can mean it says, okay, this number is bigger than what you have in dollars because the unit is smaller. Yeah, whereas we can say it's okay. Now looking at these three, this is the biggest number because this is the smallest unit of all these three, right? Did that make sense? But then just also looking here, we can mainly say, okay, that since all these are equal, that's mainly as okay, that okay as 1 dime is going to be equal to as okay 1/10 of a dollar. Or we can even say that okay, this is going to be like this. That is what 1 dime would be equal to. Or it could be 0.1 of a dollar. Or as we just wrote here, 1/10 of a dollar. Okay. Otherwise, it's okay, we go opposite and say, well, okay, 100 cents. Well, okay, it's a bigger number because it's a smaller unit, but it's going to be equal to 10 dimes. Because 10 of that's going to be a number that is smaller than 100 because it is expressing a bigger unit. But those 10 dimes is going to become just $1. Okay, where dollar is okay, or where 1 here is the smallest number because it is the biggest unit. Did that make any sense? So it's just a matter of holding this here this way or holding it like this.
Okay, so my next question is, no matter the if it's going from a bigger unit to a smaller unit or the smaller unit to a big unit, the answer will still be the same?
No.
No, okay.
Because one is going to be a multiple, one is going to be a fraction. Okay.
Okay, thank you.
If you have a penny, you only have a fraction of a dollar, right? You really can't say that 1 penny is equal to $1. Clear? If you say so, well, my dear, I have a lot of pennies that I want to just okay get converted into dollars. So I give you a penny, you give me $1. Right, okay. Okay, dear. And you need to know, yes, okay, how many of what unit comes in what unit. Okay. Now, if it is from a big, yes, okay, a bigger unit's worth being expressed using a smaller unit, you will have a bigger number. Or we can say, okay, a multiple of 10. Where, okay, if you go the other way around, you will have a smaller number or you will have a fraction. Because actually writing, listen, and that's why I said in the beginning that, okay, writing something like this, we can take any number, we can say it's okay, 2 multiplied by 10 raised to the power 3. This actually will be 2. And this 10 raised to the power 3 here actually means 10 multiplied by 10 multiplied by 10. Clear? So 10 times 10 is 100, times 10 is 1,000. So that actually is okay, becomes 2,000. Did that make sense?
Yes.
Now, if we take the same 2, but write it with the exponent, let's say it's okay, 10 raised to the power minus 3. Now, what is it that this minus here is going to indicate? That the number that we will be getting is going to be as, okay, either a fraction. Fraction can also be expressed as decimals. So this will actually as, okay, become 2. And now since it is a negative exponent, we can do it like this. It will become 2 of 1,000. Did that make sense? This could also
Yes.
be written as 0.0002. Did that make sense? So here we have 2,000. Here we have, okay, yes, 2 of 1,000. Did that make sense? But you actually can say that, okay, here we had, let's say, 1,000 cupcakes. Out of those 1,000 cupcakes, how many did you get? You only got 2. So you got 2,000 of the amount of cupcakes. So here's, okay, you have 2,000 is a great number. All these here, okay, both of these here, I mean, it's okay, just one is a fraction, the other one is mean it's okay, a decimal. But this 2,000 here can also be expressed as 2 multiplied by 10 raised to the power 3. Since, okay, whenever it becomes a fraction, the exponent will always be negative. Practically, the exponents here will be positive, but we don't write it. So if you don't see any sign, it's okay, against the exponent, it is understood that it is positive. Did that make sense? So we only actually, we actually only write the negative exponents, which automatically makes it a fraction or a decimal number. Did you girls get that? So listen, a smaller unit is always going to be a fraction worth of the bigger unit. Any questions?
No.
Okay. Any of the new girls have a question? Okay, girls, let's just see. Or you can say it's okay, or basic unit, right? Okay. Yeah. And what were these? These were all positive values, or we can say it's okay, multiples. Practically, it's okay, multiples of our unit. Clear? Whereas, okay, as if we go on the other side, is that clear? Right, okay. Now, girls, you just asked me. But let us say that now if we, for instance, okay, want to just okay, convert. The basic concept is going to be the same, but that's okay, we can say, okay, we convert from a bigger unit over here to find its word being expressed in a smaller unit from over here. Yes. So which bigger do you want GSOK get expressed using a smaller unit? Somebody asked me. Anybody?
The centimeter, the centi.
Okay, Dr. King, you probably didn't get my question. I say we first going to go from a bigger unit to a smaller unit. So
Oh.
give me a bigger unit first.
Nano.
Okay,
Wait, which side are we on? Left or right?
which is a bigger unit?
The right side.
Okay. Go ahead.
Can you do mega to milli?
So we say mega to milli. Who was that?
Me,
Who asked me that? Who is me?
Haley.
Hey, okay, good. We can say anything, right? Okay, we can say bum 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 bum. Okay, and we just say it's okay. We have 1. Now, what is mega? It's 10 raised to the power 9, right? What is milli? 10 raised to the power -3. And what we actually will do here is we will say 9 plus -3. Now, does anybody know the answer for that?
Excuse me, is mega just 6, not 9?
Also, thank you, Dad. Thank you. Somebody will come up. Okay, sorry. So 6 plus -3. No? Now, girls, you just go. 3, 4, 5, 6, 7, 8, 9. So the answer is 9. And now comes the same. Since we are so okay, are converting or determining as okay the worth of a big unit being expressed in a smaller unit. It's mainly as okay that's going to be 10 raised to the power 9. So we can actually say that okay, as in 1 mega, there's going to be as okay 1 billion millis. Did that make sense? Now, if we just do it the opposite way and say, okay, then, okay, how many millis? Will we have in a mega? Well, it's the same 10 raised to the power 6, right? Thank you, dear. Okay. And milli, 10 raised to the power 3. It's still the same because, okay, here we just count from here. 1, 2, 3, 4, 5, 6, and 9. But since we went from a smaller unit to expressing its worth in a bigger unit, well, okay, we can say this one is still going to be 1, or it's going to become 10 raised to the power minus 9. Did that make sense? So that would actually mean that, okay, as 1 milli is actually equal to, yes, okay, 1 billionth. Because this 1 10 raised to the power minus 9 actually is going to be, yes, okay, 1 billionth of a mega. Did that make sense? So girls, when we cross the 0 line, we don't subtract the exponents. We are not looking for the difference of the exponents, but we actually are looking at the sum of the exponents. And that's sum of the exponents between, yes, okay, the 2 units from which we want to convert is going to be written as an exponent to the unit. Where, okay, when we get from expressing or calculating as, okay, a bigger unit's worth expressed as a smaller unit. A smaller unit is going to be as, okay, a multiple. Where is going to be the opposite when we go from, okay, as expressing the worth of a smaller unit using a bigger unit. So the only difference here is that, okay, as we actually, as, okay, just add the exponents. Or if, as I said earlier, it's okay, if you remember the timeline that I talked about. We had here the 0, right? Right now we are in 2023. Something that happened, let's just say it's okay, 2,000 years BC is going to be as, okay, so here we can say it's okay, there's year 1000, then we have year 0, then we have, okay, as year 1000 BC, and then 2000. So we go as, okay, we can say, okay, this is 23, 1023, 2023. Then we go 3023, 4023. So some is, okay, 2000, so 4023 years ago, it was year 2000 BC. It is 2000 year BC, but it is 4000 and 23 years ago. Okay, so that's okay. You mean it's okay. Just add the exponents once you cross the zero line. Beside that is okay. It is mainly as okay. That's the same as we did. Whether we were on this side or whether we were on this side. Convert it from a bigger unit, finding its worth in a smaller unit. You will multiply. Or using a smaller unit, finding its worth using a bigger unit. You would either, as okay, multiply by a fraction or multiply by a decimal. Or you can say it's okay, maybe it's okay, just divide by okay the number. So here you actually say, okay, if I divide 1 by a million, you actually get 1 out of a million. Or billion, sorry. Is that clear?
I'm a little confused.
Oh, okay. We can still take another example. Or what is your confusion, my dear?
With the second one, when we did the 1 milli to the mega, I'm confused on how we got -9 for the exponent.
Because, my dear, we went from a smaller unit expressing its worth in a bigger unit. Because what do we mean by a negative exponent? The negative exponent automatically negative exponent, whereas -6, -3, -4, -5, -2, -12, whatsoever. These negatives here mainly as okay. All the exponents means that these are fractions or decimals. Did you get that, my dear?
Yeah.
Right, okay, so mainly because my idea is okay, milli, if you look at the scale, it itself is okay, is on the negative side. But that's not the point here. You can even have gone here and say, okay, this and this, or this expressed as this, you will still end up with a negative. Because you start off with a smaller unit, trying to express its word using a bigger unit. So again, yes, okay. You bring me, yes, okay, 25 cents and ask me, how many $100 bills can I get for this one here? I say, none. You can only get it, okay, as a small left corner of a $100 bill. Did that make sense?
Yeah, it did.
Okay, whereas, okay, if you bring me $100 bill and say, okay, Mike, how many, yes, okay, quarters can I get for this? I say, it's okay, you can get $400, you can get 400 quarters for it. So that $400 is actually going to be, as okay, if you look at it. Right, okay. Oh, 400 quarters, sorry. Okay. 400 quarters, but okay, you can actually see that it's okay, 4 multiplied by 100 raised to the power 2. And that will be as okay, sorry, quarters, which is still going to as okay be equal to $100. But if you bring me the same $100 and say, well, okay, how many dimes can I get? Now I will then say, okay, dear, we're talking dimes. You can get 10 raised to the power 10 dimes. For your dollar, for the $100. Or what this 10 raised 10 times 10 actually here means is that you can get, okay, yes, 100 what? Dimes. No, sorry, what the hell? Sorry. This was raised to the power 2, sorry. So you actually okay get 10, or you actually get, sorry. Because this will actually become 100 and then multiply by 10, so that becomes 1,000. So for your $100, you can actually get, okay, yes, 1,000 dimes. But if on the other hand, you bring me 1 dime, and I say, well, okay, how many $100 bills can I get from that? Well, I will say you can only get 1,000 of a $100 bill for your dime. Now this is made as, okay, just a fraction, but this can also be expressed as 0.001 of, okay, yes, $100. Or we can say 10 raised to the power. Now, since it is a fraction or it's a decimal, you automatically have, okay, as a negative exponent, which in this case is going to be, right? Of $100 bill or your dime. Right. Like I say, it's okay, you can bring the remaining 999 dimes and get the remaining 999 pieces of the $100 bill and then put them together. Did that make sense? Why you have a negative exponent here? Whereas generally speaking, yes, okay, the difference between mega and a milli is million. But if you go from bigger to smaller, it's going to, yes, okay, be in million or in billion, sorry. Whereas if you go from a smaller and expressing it as, okay, using a bigger unit is going to be a billionth. Did you girls get that? Or maybe
Yeah.
we can just, okay, or maybe we can just, okay, yes, just follow the, okay, yes. Because it's okay, the safety shake, oh, yes, okay, we can shake, okay, as another example. So is there anybody who, yes, okay, it doesn't really matter. You want to go from big to smaller, from small to big.
Small to big.
You want to go small to big. Okay, no problem. Good. So what small unit do you want to use?
Can we do micro to hecto?
Micro to hecto, right?
Yes.
Okay. That's a small jump, but anyways, that's fine. Well, what was your micro, my dear? That was 10 raised to the power minus 3, right? Clear? What was your hecto? Sorry. Shit. 10 raised to the power 2. Now you can mean, yes, okay.
Isn't micro 10 to the -6?
Oh, she said, okay, so micro 6. Okay, thank you, dear. Who was that?
Haley.
Haley, good. Thank you, my dear. So, okay, micro 6. Okay. Good. -6. Now, what do? We just do the same. 3, 4, 5, 6, 7, 8. Now, okay, me says, okay, here, 1 will be 1, 1 will be 1. Okay, Bobby me says, okay, 1 micro. Now, since we went from, yes, okay, from a smaller unit to express its worth in a bigger unit. Okay, and we said, okay, that the difference was 3, 6, 7, 8. So this is going to be 1, 10, and the exponent is going to be 8. But we went from small to big, so we actually are going to say, okay, just have a fraction. So what would that mean? That 1 micro actually is going to be equal to 1 over 100 billion, 100 million, or 100 millionth of a hectare. How do we get this 8? Mainly as okay, you can say, okay, we have 0. So from 6 to 8, it's 6, 7, 8. But because we went from, okay, as a smaller unit expressing its worth using a bigger unit, we're ending up with a fraction. So either you want to write it like this, or you want it to write it like, no, it's a fraction, so we can mean it's okay, just do it with this code here. And then you just go, yes, okay, 1. And then you can go on and count your zeros. 1, 2, 3, 4, 5, 6, 7, 8. Or it can actually is okay, be. Or just okay, written as a fraction, so as a decimal. So we go 0 point. And then we just go 2, 3, 4, 5, 6, 7. Like this. Okay. So that's what 1 micro is going to be worth if we express it as using the unit hectare. But if we went the other way, and we said 1 hectare is equal to, yes, okay, how many micros? Now the difference between the says, okay, we can say, okay, between the exponents, it's still going to be 8. So it says, okay, multiply by 10 raised to the power 8. Which means that there's going to be, it's okay, 100,000. Oh, sorry, 100 million. 100 million micros will make a 1 hectare. Or you can even say 100 million. Or it's going to be 100 millionth. Any questions? That's fine, girls. When we go through, yes, okay, the exercise questions, I may say, okay, this was the answer here. But if you flip the units a little around, this would have been answered then. This would have been answered then. So you can probably check it up at that point. Okay, now one thing, okay, now it's mentioned in your book, but it's okay. I mean, it's okay, just want to write it side by side. And you can maybe, it's okay, look at it. And we can, it's okay, hopefully it's okay, try to agree upon that. And that's mainly going to be that we can say, we just make our scale up here, just for a comparison. So 0. We say Eka, hecto, kilo, mega, and giga, which is 10 raised to the power -1, 10 raised to the power 2, 10 raised to the power 3, 10 raised to the power 6, and 10 raised to the power 9. As on the other side, we go deci, centi, milli, micro, and nano. Where we say, okay, this was 10 raised to the power -9, 10 raised to the power -6, 10 raised to the power -3, 10 raised to the power -2, and 10 raised to the power -1. Is that clear? Now just keep in mind that, okay, these here can also be expressed as, that's fine. Now, we can then now say that, okay, as a nano and giga are reciprocals. Likewise, can we say that, okay, as a micro is reciprocal to a mega? A milli is reciprocal to a kilo. We can even say that, okay, yes, centi is reciprocal to a hecto. And deci is reciprocal to a deca. Yeah. Now, if you for instance say that, okay, as a giga was 1 million. 2, 3, 4, 1 billion, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 zeros. And we now multiply this by a nano. which is 1 billionth. 1, 2, 3, 4, 5, 6, 7, 8, 9. What do you have? You can straight away say, okay, it's this, that's this. And what do you have? You have 1 left, right? So what does that mean? That when the product of 2 things is equal to 1, that's going to be reciprocal. So likewise, that's okay for your micro. We can go on the basic. Now micro, that's going to be as okay 1 over a million. And a mega multiplied by a mega. Which is 1 million. 8, 2, 3, 4, 5, 6. So what do we do? Scooby-Doo. You can either multiply this. That's okay. 1 multiplied by a million divided by a million. Is a million divided by a million, what do you get? 1. Or you can just go this million, that's this million. And what do you have? 1. Capiche? Next, we can say it's okay, 1 million, which is 1 over 1,000, versus a kilo, which is 1,000. And when we multiply these two, well, okay, it cuts out. We have 1. So that makes millions and kilos reciprocals. Or even if we say, okay, what was the reciprocal of 1,000? The reciprocal of 1,000 was 1 over 1,000, right? Right? Now, this 1 over 1,000 here could also be expressed as 0.1 or 0.001. Clear? Whether you multiply this by 1,000 or this by 1,000, product is still 1. Did that make sense? So girls, especially for these 2 units here. These are the ones that you most likely as okay will be coming across to convert. And that's going to become relevant because you may actually as okay come across different parameters that we will say will be reciprocal to one another. So if one is expressed in megas, the other unit will be expressed in micros. Okay. If one is going to be expressed in kilos, the other will be expressed in millis. But you can even go as okay, say if some is that 2 things or 2 parameters which are reciprocal to one another, if one is expressed in gigas of its own unit, the other is going to be expressed in nanos of its own unit. because they are reciprocals to one another. So in many cases, it's okay, you do not really, it's okay, actually need to do the calculations. What was it that we said about reciprocals? One is 10,000 great, one is 1/10,000. And another thing was, okay, when we multiply reciprocals, they become, the result is 1. So you multiply 1 million by 1 millionth, or 1/1,000,000. You will have 1. You have 1 million cupcakes, and you invited 1 million guests to your wedding. How many cupcakes is each person going to get? It's going to be 1 cupcake per person. Now, if half of your guest list doesn't show up, you still have 1 million cupcakes. But you only get, okay, half of the guests. Well, okay, then good for the people who showed up, because now they will have 2 cupcakes each. But then on the other hand, you will say, well, okay, I send out as, okay, 1 million invitations, but only 500,000 of people as, okay, RSVP'd me. That means that I don't really need to make 1 million cupcakes. I'd be good, but okay, it's just 500,000. So half is reciprocal of a whole. Right? Any questions? Okay, girls, so chew on the things that we did today. It may be as, okay, a big bite, especially as, okay, if you were the only guest who showed up at the wedding. 1 million cupcakes there. No, okay. Have fun, because this is just the appetizer. The meal is still coming up.
I'm already full. No, thank you.
Good. So tomorrow is okay. What we will be doing is, okay, we'll try to just, okay, look at the questions and the review at the end of the chapter. And we'll go back to, yes, okay, to the exam, and it's okay, try to, yes, okay, look at those questions as well. Okay, I think there's some 22 questions in the exam review for chapter number 1. Some of them are dumb questions, but I mean, it's okay, just a matter of, okay, as understanding, yes, okay, the basic concepts here. Okay. So let me just say that, okay, as the first 3 chapters is mainly as, okay, just going to prepare you for the 4th chapter. Which is going to prepare you for the 6th chapter. Which then, well, yes, okay. So yes, okay, as we go through more and more and more, things are going to, yes, okay, make sense, or starting making sense. Okay. So as we proceed, yes, okay, I will say, okay, good, listen, girls, do you remember that thing back from that chapter? Here, yeah, okay, here, that's very, okay, it's explained more, yes, okay, in detail, or okay, yes, more to the point whatsoever. Oh, that makes sense. So hopefully it's okay, as we go through this whole thing, is okay. you get, okay, some more and more and more and more complete, okay, as overview of this whole thing here. And by the end of the module, yes, okay, you'll be good. Hopefully, right? Cross fingers, cross toes, cross arms, cross whatever. Okay, girls. Any last conversion that somebody want to ask about? So how many hectares do we have in a kilo? Or how many hundreds do we have in 1,000? That's what I asked.
10,
Huh?
10,
I can't hear you, my dear.
10, 10.
10. Okay. Thank you. Good.
I wasn't sure.
No. Clear? Okay. Now, how many centis do we have in a micro?
What did you ask?
Ye-
How many centis do we have in a micro?
Is it 10, 100? I don't.
100?
Oh,
10,000? 100,000.
it's 100,000
Thousand. Oh.
because we went from a bigger unit. A centi is bigger than a
Milli. Micro.
micro.
Sorry.
That's fine. You will get there.
Hopefully.
Okay. Just once in a blue moon, yes, okay, I may just randomly, yes, okay, pop the question. But I gave you the cheat. As long as you know the exponents, you should be good. Now, what does it mean? It's okay, what would 10 raised to the power 4 mean?
It means that the number is in the.
No. What would it be?
Oh,
10,000?
Huh?
yeah, 10,000.
10,000?
Yeah, 1,000, right? 10 raised to the power 4 is 1,000, right? No, my dear. 10 raised to the power 4 is 10,000. 10 raised to the power 3 is 1,000. 10 raised to the power 3 is 1,000 because 10 times 10 times 10. That's what it means. So 10 times 10 is 100, times 10 is 1,000. You multiply that 1,000 again 10 times, it becomes 10,000. So that would be 10 raised to the power 4. You multiply by another 10, that would have been 10 raised to the power 5. It become 100,000. You multiply again by 10, that would be 10 raised to the power 6. It becomes 1,000,000. Clear? Okay, girls. See you ladies tomorrow, okay? Hopefully it's okay. We'll be able to, it's okay, finish off with shit. The exercises for the chapter here and the exam review. And okay, let's head on to the second chapter. Or why shouldn't I do it this way? You do that as your homework. Clear? And what we then can do is, well, okay, if there's any questions that you have any questions about, well and good. Okay, and I think that's okay. If you go into the back of the book, it's the first 20. No, not even, okay, yeah. Yes, the first 22 questions in the exam review from page 423 to page 427. So the first 22 questions. Clear? And then, okay, that's the questions at the end of the chapter. From page 6, 7, 8, 9, and 10. Clear? So in the exam review, yes, okay. The first 22 questions. That's in the back of the book. On page 400 something plus. Okay. Now, most of these questions are okay, yes. At least you can say some of these questions here are going to be, it's okay, a little bit weird. Or dumb. But yes. And then we can try to, yes, okay, go over them together. So that's okay. If anybody still is in doubt how the answer came out to where it was, okay, good. And once we get to just, okay, some of the real interesting questions, that's okay, we can actually, yes, okay. So yes, okay, start play around with the units and so on, so as well, okay? So make an exercise of the exercise. Does that make sense?
Yeah.
Okay, I'm not going to be holding you girls back. Some of you may have to leave or have more important things to do than sitting here and listening to me. So, okay. Bye-bye.
Bye. See
Bye,
you.
girls.
Bye.
Thank you.
Bye-bye.